How do you calculate the exact size of the Earth when you are living 1,000 years in the past, long before satellites and modern surveying equipment? The answer begins in the year 973 in Khwarazm, a thriving hub of the Islamic Golden Age, located in modern-day Uzbekistan. This was Abu Rayhan Al-Biruni's birthplace. His early life was defined by intense political instability. Competing empires repeatedly fought for control of Central Asia. By his 20s, invading armies had forced al-Biruni from his home. He spent years as a political captive, swept along with military campaigns that marched through Ghazni and deep into the Indian subcontinent. Many scholars of his day deferred strictly to ancient Greek texts, treating Aristotle's writings on natural philosophy as unquestionable law. Al-Biruni rejected that approach. He insisted that knowledge required direct observation and physical evidence. If a theory couldn't be tested, he wouldn't accept it. Being pushed out of his native library forced him into the field. His life as an exile turned him into an active, rigorous observer of the physical world. In the year 1017, his forced travels brought him to the Nandana Fort in the rocky, arid mountains of present-day Pakistan. This rugged terrain provided the perfect laboratory for his mathematical theories. He devised a way to measure the Earth using local geography. Standing on the plain below the fort, he used an astrolabe. Measuring angles from 2 points a known distance apart, he used trigonometry to calculate the mountain's exact height. Then he climbed to the very top. Looking out over the plain, he measured the slight downward angle, the dip of the horizon. Combining the mountain's height with this single downward angle, he calculated the curvature of the planet itself. In this historical manuscript, you see the precise sine formulas and geometric proofs he used to arrive at his final number. He calculated the Earth's radius to be 6,339.6 kilometers, which is within 1% of the actual equatorial radius measured by modern satellites today. He captured the vast scale of the entire globe using a single mountaintop and mathematical logic. Mapping the Earth locally was one thing, but measuring the longitude between widely separated cities like Baghdad and Khwarazm presented a severe logistical problem. They had no standardized clocks to synchronize their measurements across hundreds of miles. Al-Biruni and a colleague in Baghdad realized they could use the sky itself as a universal clock. By agreeing to observe a specific lunar eclipse, they recorded the exact local time the moon entered the Earth's shadow from their respective cities, hundreds of miles apart. The difference in their local times allowed them to calculate the exact distance between them. To ensure absolute precision in these observations, Al-Biruni designed complex mechanical instruments. This diagram illustrates one of his geared devices, engineered to track the continuous motion of the sun and the moon. Combining precise longitude readings with calculations of the Earth's total circumference, he realized the known continents of Europe, Africa, and Asia covered just 2/5 of the globe. Relying purely on the data, he proposed that a massive, undiscovered landmass must exist in the remaining ocean, predicting the Americas nearly 500 years before European explorers arrived. His demand for exact measurement extended down to the microscopic level. This illustration shows a specialized specific gravity vessel, or pycnometer, that Al-Biruni invented. By measuring the water displaced by different metals and gems, he determined their exact densities using mathematical ratios. He took the same objective, analytical framework and applied it to the people he encountered during his travels with invading armies across the Indian subcontinent. Instead of relying on second-hand accounts, he spent years teaching himself Sanskrit. He engaged directly with Brahmin scholars and translated local literature to write Kitab al-Hind, a comprehensive ethnographic study of Hindu religion, philosophy, and science. He documented their beliefs with remarkable neutrality, separating his own cultural biases from his research. He studied a foreign civilization, which his own empire was actively fighting, with the exact same dispassionate respect that he applied to a geometric proof. Al-Biruni compiled a library of over 140 books across astronomy, mathematics, geography, and sociology, and he did almost all of it while navigating war, surviving captivity, and operating far from his home. We still recognize the physical instruments he conceptualized, early pyknometers and geared astrolabes, but his enduring contributions are the methodologies he left behind, like using mountain horizons for planetary measurement or eclipses for mapping longitudes. His life provides a clear framework for inquiry. Demand physical proof, remain skeptical of inherited tradition, approach different cultures with an open mind, and continue to investigate the world regardless of your immediate circumstances. Abu Rayhan Al-Biruni calculated the boundaries of the earth, and in doing so, proved that the pursuit of truth is not bound by borders.